Take three. Take three. We're gonna get this one done. Dhruv, how you doing, man?
I'm doing great, Peter. Thank you for having me. How are you?
I'm good, man. This is your third appearance on the podcast. It's just the first one we were actually getting done.
Yeah.
Shinobi, how you doing, man?
I'm doing all right. I am amazed. I have been without nicotine since the 4th of July, and I'm not ripping my face off. So,
Congratulations.
oh, come on, Peter. I saw that. You were supposed to quit
What?
with me, dude. You were supposed to put that down with me on the
Dude.
4th in memoriam to England getting their ass kicked.
Yeah, well, this is you getting your ass kicked. I'm gonna blow smoke the whole. I actually gave up. I'm just having it just for this session to fuck with you. Anyway, listen, we've actually got important stuff to talk about. Okay, firstly, a big thank you to Ben Prentice for coinciding this exactly at the same time as Jack Dorsey and Elon Musk were about to talk.
Yeah.
So, thanks for doing that. I think this is a much more important conversation, unless you're somebody who's hoping and praying your bags go up. Dhruv, you reached out to me, you reached out to the team. We don't really know each other. All I know about you is you're a core developer. So you should introduce yourself to the listeners, tell them all about you and what you're working on.
All right. So, yeah, I would like to tell you a little bit about why I work on Bitcoin, followed by what I am doing for my project right now. I grew up in India in the 90s, and outside home, the world looked like it was financializing. Companies were coming to India. There was globalization. These tall glass buildings were showing up. I wanted to work in one of them so bad. And at home, we still had a lot of traditional influence. Friends would talk about stocks, and at home, people would talk about gold. They were gifting each other gold on birthdays and anniversaries and whatnot. And as a kid, I just didn't get it. I thought we had access to these amazing assets, and we were still gifting each other this thing that was clunky, could get stolen. You would go to the market, and the guy would use a black stone and scratch gold on it and then tell you how many carats it was. And you just kind of were like, okay, well, that's the purity of it. I didn't really get it. But then a decade later, I saw what 5 to 15% inflation had done to my parents' ability to buy a modest 2-bedroom apartment in a tier 2 city in India. They'd worked hard, they'd had good luck, but these stores of value like the dollar, gold, real estate had gotten so expensive that it was hard to be retired in a reasonable way. After I learned about Bitcoin, I learned how all rulers basically manipulate money. India has cultural memory of the Maharajas and the British, and even their democratic government demonetizing their hard-earned money or clipping coins or whatever they did in the past. And the response to that they developed is gold. So that's the justice angle of why Bitcoin is really important to me. But my naivety continued, and I worked early in my career at companies like Google, building the search and ads infrastructure. I started a Y Combinator-funded marketing automation startup. And I helped build the surveillance state. I learned it from inside out as I built it, but I helped build it. And now that I've realized what I've done, I'm kind of ready to blow it up. And I truly believe fix the money, fix the world. It should be fix the money, fix the incentives, fix the world. But I'm here to do it. And the project I have picked to work on has to do with the verifiability of our money, of Bitcoin. So you on your podcast, you've talked previously about the properties that make a good money, right? Scarcity, durability, divisibility. And verifiability is the one that's most important, the peer-to-peer layer of Bitcoin. So I recently got started on my project to make that running a full node, which is essentially the verifiability of Bitcoin, more robust.
Nice, man.
Yeah, that's the why.
That's the why, man. Well, listen, I'm glad you reached out. Must remember we've got our degenerate regular Shinobi on the show. How are you doing, man?
Who gives a crap what fucking Elon's doing right now? This is so much more important.
All right, brother. Well, listen, Dhruv, I'm glad you reached out to me because you want to talk about an interesting topic. I self-confession, Ben did a lot of the preparation work for me. In going through it, it's kind of like, this is a really important topic. This is an important subject. You were like, I want to talk about internet architecture as it is very important towards Bitcoin. So we're going to dig into how the internet works. So How decentralized is the internet itself?
Yeah, that's a great question. And the TCP/IP, which is the protocol, is very decentralized. The internet as we use it is extremely centralized, right? TCP/IP decentralized, internet super centralized. And the reason for that is that there are three primary sources of trust we regularly use when we're on the internet. So I want to walk you through an example of what happens when you go to a website in your browser, and then we can talk through the sources of centralization there. Does that sound good?
Yeah, sounds great.
Okay, so let's say you go to bitcoincore.org or whatbitcoindid.com. The first thing that happens is your computer has no idea where this website is hosted, right? So it does something called a DNS lookup, so domain name service lookup. These are servers that are typically run by ISPs or big tech companies like Google and Cloudflare. So your computer goes, your browser asks the operating system, where is whatbitcoindid.com? Goes, I don't know. I guess I'll go ask the DNS server. It asks the DNS server, you get back an IP address, which is, you've seen these like 4 numbers separated by dots, right? 192.168. You might have seen that for your router at home. You get back an IP address, which is where the computer is that hosts that website. So that is the first source of centralization, is that DNS lookup, because you have to ask someone is a central entity, where the other computer is. That entity is corruptible, right? Instead of going to your web computer for your website, the ISP could decide to send it to Shinobi's computer, and Shinobi could host like a homepage that says, haha, Peter, you should quit smoking, right? And that's a DNS hijack. That's the first source of centralization. Let's say everything goes okay and you get back the right IP address. The next thing that has to happen is your computer has to figure out how to reach that computer. Not every computer in the world is directly connected to every other computer. So you're going to go, hey, how do I reach this IP address? Your computer has no idea. It asks your gateway. It typically has no idea. It goes to the ISP. The ISP runs these servers along the way called routers, which will route the traffic. So, somewhere up in California here, the ISP will say, okay, this looks like an IP address that is in the UK somewhere. I don't really know where, but it's going to send it to the UK node. And then in the UK, perhaps it knows it's closer to Bedford and how to route it. So there are these IP routers along the way, which are trying to get you from one IP address to another IP address. This is another source of, it's a corruptible entity. It's a source of information where you're putting in trust to find the other computer. Your traffic could get directed to the wrong computer because the ISP decided to hijack your IP address. And this attack is called the BGP hijack, a border gateway protocol hijack. Because the border gateway protocol is the technique used to update these tables along the way, the lookup tables, which help you find any computer on the internet. Does that make sense so far?
It does. But also the way you were describing the way it routes sounds a little bit almost like the Lightning Network.
Exactly, it does. The only difference really is the liquidity requirements, but like routing on Lightning is the same general problem as routing on the internet.
All right, so yes, that's clear so far.
Okay, so I just want to say it's a little bit different than the Lightning Network because for the Lightning Network, you get to pick the path. You can even do things like you can pick 2 paths with multi-path payments and you can put them together. You can do a lot of different things as the sender. However, with the internet, ultimately, there are only so many C-links and these entities control them. And so it's not like you really get to pick your path. You go through some sources of tremendous centralization. On the Lightning Network, you don't like a source of centralization, just spin up a node, add liquidity, and that's no longer central. You can't do that on the internet. So it's quite different in that sense from the Lightning routing. The third source of centralization on the internet is certificate authority. So let's say you get sent to the right computer. it sends you back a website. How do you know that the website is, the content of the website is really coming from where you think it's coming from? And we don't have to go into kind of the details of this particular source of centralization, but essentially they send you back a cryptographic signature, and your operating system comes baked in with certificate authorities that can verify that, yes, you are indeed on Amazon.com, or you are indeed on whatbitcoindid.com. So those are the three sources of trust that makes the internet very centralized: DNS, IP routing, and then certificate authorities.
Okay. And just out of interest, could those centralized entities that we rely on to run the internet, could they ever become decentralized, or is that one of those things where you just kind of have to accept that's the way it is?
I think it's very important to distinguish between the protocol and the infrastructure. So TCP/IP, the protocol, is extremely decentralized. If you and I really wanted to connect our computers with the Ethernet cable, we don't have to go over an ISP. TCP/IP is decentralized. Because there are so many people that want to connect to the internet, we have built this hub and spoke model where the ISPs are the hubs. Everybody, it's just like the traditional financial network is also a hub and spoke model, right? We tend to start with decentralized protocols like bearer cache and end up with hub and spoke models like the traditional financial networks. Start with a decentralized TCP/IP, end up with a centralized internet, right? We're seeing this a little bit with Lightning, where we started with very decentralized Bitcoin. Lightning is, right now pretty hub and spoke. And so hub and spoke scales.
Like, some things you can decentralize to some degree right now, but just not all the way down to the base layer. Like, speaking of DNS, like where somebody finds out how to get whatbitcoindoes.com and actually get an IP address to go to. You can run your own DNS server. Like, you can cache things so that once you find out something's IP address, like, that stays on your local machine. And for that website, you don't need to go to a third party anymore. But those packets still have to go out to your ISP and then go through that routing layer, and you still have to depend on those things. But at least you know the IP address. So it's kind of like, some of the things can and are decentralized if people choose to do so. But that's more towards the coordination side of things and not like the bottom layer actually moving stuff.
Yeah, we can definitely mitigate the risks. Yeah.
Okay. Well, I mean, we don't need to get into the Lightning thing at the moment, but by the way, I don't hate the hub and spoke model personally. I know some people are like decentralized purists, but I use the Lightning Network primarily. Well, almost. I actually entirely use it using a custodial wallet at the moment because I still haven't used my Lightning node, and I don't keep too much on it, so it doesn't bother me too much. But I know that has some potential issues or criticisms. But anyway, by the by, it is what it is. Okay, so like comparatively, how decentralized therefore is Bitcoin?
Yeah, so Satoshi seemed to really deeply understand this hub and spoke issue, right? So traditional financial networks have banks as the hubs, and they can suppress any financial activity between these entities, companies, people, whatever, by just passing a law and going after the banks, because there is a CEO to go after. There is a throat to choke. Satoshi built Bitcoin in a way that there are no throats to choke. It's a peer-to-peer network. Every node typically connects to 8 other nodes. And there is no one throat to choke. My node does exactly what Elon Musk's node does. It doesn't care how many followers he has on Twitter. There are no super validator nodes. A node is a node on Bitcoin. But ultimately, these nodes have to talk to each other somehow, right? They have to have a communication link. And today, the most popular communication link is the internet. So while the Bitcoin protocol is super decentralized, the transport layer we use today of choice is the internet. And as we discussed just now, that has sources of centralization in it, which leak into Bitcoin. And what I want to talk about as an example of this, and to drive toward the projects I'm working on and motivate that, is how how this affects existing nodes and new nodes when they come online. So when you have an existing node, it already has something called AddrDB, address manager database. It knows thousands of peers that it can talk to. So it can choose from them and talk to them. And because proof of work consensus is such a strong property, all we need is one honest peer, which is connected to the honest network to know the truth. Everybody else can lie to my node, but if I can connect to one honest network, my node will know the truth. This is wonderful, except when your node doesn't know any peers yet. So you just spun up a new node. How is it going to find out the truth of all transactions that have happened? So what we're trying to figure out is the UTXO set, and the blocks are these diff patches on the UTXO set. We're trying to find that truth of the current UTXO set. So my node comes up, doesn't really know any peers to talk to. And this is where the risks from the internet leak into Bitcoin, where my node has to go ask someone, hey, tell me a few Bitcoin nodes, right? Who should I talk to? Once I know a few, I can ask them who their peers are, and I can ask them who their peers are, and I can crawl the network. But in the beginning, I have to go to someone. And so today, the way this works in this query response system that the internet is that there is something called the Bitcoin seeder. It's a separate repository of code than Bitcoin Core. In Bitcoin Core, there are 9 domain names that are hard-coded. These are run by long-term Bitcoin contributors, and they run seeders, which are crawling the Bitcoin network. So people like Peter Woola, Matt Corallo, Luke Dash Jr., they're running these nodes. They have a lot of real-life proof of work in the Bitcoin ecosystem, so we trust them to run these nodes and be honest with us. But the first thing my node does is it has to resolve a DNS address. So one of the DNS addresses here is seed.bitcoin.sipa.be. One of them is dnsseed.bluemat.me, which means that my ISP can attack the seeder. If I'm using my ISP as a DNS server, it could send me to a dishonest seeder, which would seed me with dishonest peers, and I will never find out the truth because I'll never find even one honest peer. Does that make sense?
Well, a little bit, but more in that sounds risky. So how do you mitigate that?
Well, it's only risky if you get caught. And if you are the person who is controlling the DNS names, what they resolve to, your access to the internet, like you're going to have to go out of your way to find a new source of information for them to get caught. And until they get caught, they completely control your view of the Bitcoin network. They could just stop feeding you blocks after like block 600,000. If they have the energy and the resources, they could mine fake blocks on top of block 600,000 and then give you those fake blocks. And because they've completely controlled who you connected to on the network, you're only connected to people who will give you those fake blocks and go, yes, these are real. And so, like, if they catch you when you're bootstrapping onto the network like that, especially if they have the energy for proof of work, they can just completely lie to you. And there's no way to figure that out until you find a new connection to try to, talk and find other peers on the network.
It doesn't sound like there's much of a reason to do this, though. It's a lot of effort for what benefit? Because they can do it at an individual level, maybe a few individuals, but if we've got tens of thousands of nodes already live, it's not like they can disrupt the entire network.
So this was the attack on new nodes, right? There's a separate attack they can do on existing nodes, which also I want to talk about. So we talked about IP routing, how computers talk to each other on the internet. This is surprising to many people, but Bitcoin peer-to-peer traffic is actually in plain text. It's completely unencrypted. So when my node sends you a block, along the way, you can inspect the TCP packet and you can see the peer-to-peer command. You can inspect the packet size. the Bitcoin protocol is very easy to fingerprint, and you can just drop the packets. Like the router could just say, nope, this traffic just doesn't go to the next node. There are a lot of countries in the world where there is only one like state-controlled ISP, right? How do you then, if existing nodes can't talk to each other, new nodes can't bootstrap, it's not that they can ban Bitcoin. People will find a way. People will use a satellite. People will use something else. But it's that they can make it hard to use is one thing. And then the other thing is you can lose trust, right? So if like Shinobi said, if they're mining fake blocks, I could be giving up my labor or selling goods and services for fake Bitcoin. And then if the system loses trust, then people will go to some other scarce asset to store their value.
Right. So they can send you blocks whereby you believe you've accepted real Bitcoin. But
it would be a hard fork technically. Yeah.
But then, the reorg comes and oops, the transaction paying you doesn't wind up in the longest chain. Like, uh-oh. And like I would even go a step further, Dhruv. Like, you can play games with this type of infrastructure to affect mining. Look at the larger tier networks like Akami or others of that scale on the backbone. What if they stopped taking blocks from this group of miners and sending them to everyone else, but would take blocks from everyone else and send them to this isolated group of miners? Like, you could start playing games with the profitability of individual miners if you wanted to start, playing with blocks flowing around, because all of this is unencrypted and you can see that.
Yeah, you can even co-opt hash rate, right? So the way these networks work is there's one node and everyone else just has hashers, and you could just, if you do a BGP attack on the full node for that network, you could just co-opt that hash rate.
So like, instead of mining with the pool you think you're mining on, that connection got cut off, and this malicious pool is having you mine on their blocks where they get paid instead of the mining pool that will actually give you your share.
Yep.
Okay. So these all sound like scary situations and sound like the kind of thing someone like me, who's just a typical moron, who would have no idea if it's happening, no idea how to check for it. I trust this trustless system that my node is fine, or when I use another person's node, it's fine. So are you saying is there work being done to mitigate these problems? Are they rare? Does it happen? Or should I have a new skill set which allows me to ensure this isn't happening?
Yeah, that's a great question. So today there's already a bunch of things you can do if you are technically able to do them, and if you are in a hostile regime, right? So you can run your node on Tor. You can be behind a VPN. These are techniques that make that traffic hard or impossible to fingerprint. But there are other issues with it, in that everybody cannot use Tor. Our block propagation times would be very, very high, which would result in kind of consensus being harder to achieve in the network if everyone to use those techniques. And also, most node operators don't have the technical expertise to set this stuff up. So there needs to be something that comes out of the box. So in 2016, Jonas Schnelli, one of the core devs, started working on BIP 150 and 151 to provide end-to-end encryption and authentication between Bitcoin peers. So there is we can go into the technical details, tell me how much is too much, but there's a Diffie-Hellman key exchange that happens between the peers, and then the man-in-the-middle attacks are still possible, but they become observable. So you can tell if you are being attacked, at least. This BIP then, in 2019, it was changed to be BIP 324, which had a lot of traction. There are a bunch of PRs that have been merged. BIP 324 gives us cryptographic assurance that we are talking to the node that we started talking to originally, and the traffic is not being tampered with. Does that make sense so far? Or do you or Shinobi have any questions on that? Shinobi, do you know about BIP 324?
Yeah, actually, I have been wondering for years, why there was not more motivation to get those types of things done. I'm especially glad though with the jump from 320 or 150 and 51 to 324. I believe weren't most of the actual cryptographic aspects of it. I think from Peter Woola and Greg Maxwell.
Yeah. They have been mentioned in the BIP as the ideas being mostly from them, and I would say we are like 60% implemented at this point. The work has slowed down a little bit, but so I got funding earlier this year from Square Crypto, Human Rights Foundation, and Gemini to work on authenticated seeds. What I want to do is I want to build on top of BIP 324. So what we can do is the seeding process I talked about, where you're talking to a seed node that you want to be sure you're actually talking to the seed node. It's not DNS hijacked or BGP hijacked. We can use BIP 324 to do a, Diffie-Hellman key exchange through the code base, or we can do a BIP 150 style kind of authentication challenge. But the work I am doing is to make sure that the seed nodes, when your node is talking to a seed node, it has cryptographic assurance that it is actually getting back results from them.
Yeah, so like an identity key, so that the node can be sure. Like instead of just the domain name hard coded, you have an actual key
Public
that they
key.
have to sign with. Mm-hmm.
Yep. And the building block, one of the building blocks of this is obviously BIP 324, because we also want encryption along the way. BIP 150 does not allow for authentication without end-to-end encryption. So yeah, that's the work I'm doing. And once you have that in place, you can be assured that your new node, if it does, you could still get censored in that your ISP might still drop all your packets going to that IP address, but you cannot be co-opted. And if a node is censored but not co-opted, the node operator will typically find another way to do it. If you're co-opted, you might not even know that you've been co-opted. So it eliminates that completely. And we take the risk that was technical previously in terms of DNS and BGP hijacks, and we reduce it to social risk, which is, are the 9-seaters really honest?
Let's go further than the 9-seaters. That's a massive starting point, but what about general, just plug in a key? Like, why do I have to go to a DNS bootstrap node? Peter, give me your node's identity key. I know you, Peter. I trust you. I want my node to first connect to your node because I think you did that right. I personally know you. And there is way more trust there than just this ephemeral group of developers.
Yep, and that will become possible as well with these projects, because we already have the seed node command line flag with the Bitcoin Core node, and you essentially would seed yourself with Peter's node and know for sure that you're talking to Peter's node, because we will have end-to-end encryption and authentication. So that will totally become possible. You won't have to rely on the 9 default seeders.
See, this is one of these conversations I feel like it's really super important, but I'm just like, okay, what am I meant to do? I like Bitcoin. I've been told I should run a node. I've set up my node. I'm under the belief that now I'm running a node, I'm able to validate UTXOs. And now I'm like, but are these real blocks? Am I being scammed? I have no idea what I'm meant to be doing now. Like, how prevalent is this on the network?
Yeah, it's a great question. I feel like, did you see that recent Alex Gladstein tweet? It was something like, the price of freedom is eternal vigilance. It's kind of like that. Like we're backing, $500 billion, $1 trillion of monetary value. How prevalent is an attack is not really an important question. How possible is an attack is the important question. When the value is 10x of today or 20x of today, what people are willing to spend to attack it also goes up. When it starts to hurt, when it starts to hurt their ability to print money, they're going to be willing to print a lot more to spend it to protect their ability to print. And
also, like, politically, like, Peter, look at what's been going on for the last couple years. Like, you have these insane copyright movements and antitrust moves against big internet companies in Europe. You have demands for like similar things going on in the United States because of our social media issues and how that ties into politics. There are a million excuses in general politically to just start playing games with internet infrastructure. Like, the press secretary of the White House quite literally said the White House is actively approaching Facebook with things that they want like removed and censored. If Bitcoin continues growing, like, hey, yeah, how common these attacks are right now, while this is a child's toy just sitting there, doesn't matter. What about when we have superpowers going, turn this thing the fuck off right now?
Yeah, and I just want to add one thing. So what you should be doing is, I think, already what you're doing. So you're running a full node. You are doing tremendous advocacy. You've gotten people to do core dev funding to move projects like this forward. I'm funded by Gemini, which is one of the people you've gotten doing that. And then upgrade your node. So every time we do a new release and we launch these features, upgrade your node and add that layer of protection to the network.
Okay. So what we're really talking about here is like, are you saying these are theoretical attacks, or do we know these attacks are happening now?
They have happened, not against Bitcoin, but these types of attacks in general on the internet absolutely have happened. They happen all the time. Like, I think in the last couple years, there was actually a major incident where somewhere in the Middle East, like for a whole day, internet traffic for no reason was just being routed through the middle of China. And so you just have to ask yourself why, and what could China gain from but it's like these things happen.
And it's a little bit of an arms race. If somebody else has nuclear weapons, you don't ask yourself, are these sorts of attacks happening? You get your own nuclear weapons, right? It's like the fact that it's possible is enough. It doesn't have to happen. The circumstances will change, incentivizing these sort of attacks if they're possible, and we have to mitigate them before they happen and we lose credibility on the network.
Right. Okay. So how are you approaching this project? Like, how complex is it? What's the solution? Should I be worried? I keep thinking, look, at any point, like, it's almost to that point now that people say, like, if you are using a hardware wallet and you are not running your own node, you are trusting someone else's node. Well, I have to say, what do I trust more? Do I trust Ledger's node, or Cold Card, or whoever the hardware wallet I'm using? Do I trust their node more than I trust my ability to know if I'm being scammed on my node? And yes, I do.
So that's tricky, because when you say you trust Ledger's node, what you are saying is you trust literally everything from your finger on the keyboard up until Ledger's node, and then you trust Ledger's node. So you're trusting your operating system, you're trusting your ISP, you're trusting their ISP, and then you're trusting the fact that if the government shows up at that CEO's doorstep and asks them to do something, they're willing to die on that hill, right? You're trusting a lot of things. You're not just trusting that if the trust was just that their technical expertise is more than your technical expertise, sure. But it's not that. You are kind of trusting a lot of infrastructure in between as well.
But I think realistically, that's what the majority, and I'm going to put a number out there, and people might sound this is like wrong, but like over 95%, maybe 98% of people right now are trusting other people's nodes, are going through that.
Oh, it must be higher. Yeah.
Okay, so it's over 99. So it's a decimal of 99?
Sure. I think like what's important to think about is the floor of the security that the network provides, not kind of what most people are choosing to do. So if everyone runs their own Bitcoin node and everyone is using end-to-end encryption and authentication, the floor of censorship resistance, the floor of security is much higher, which means that, so today, nobody, you don't know any known attacks on Ledger servers in the UK, and you're comfortable using it. I think that's great. But I think the fact that it has a certain level of difficulty there's a certain level of difficulty to attack Ledger's node, and that level of difficulty go up, and the level of difficulty for you to run your own node come down. These are very important things for adoption. These are very important things for people's ability to put their trust in this. Because if there's one such attack somewhere, right, there's going to be a decade of FUD about, remember how that one time that government was able to do so-and-so to Bitcoin? And we keep moving the line of defense forward as core devs to make sure that the cost of those attacks keeps going up and the floor of security and censorship resistance in a hostile environment keeps going up.
Mm-hmm. I mean, like Pete, think about you think the odds Ledger's server gets messed with are non-existent. Okay, so what happens when it does? Like, what do you do? What's your option? I'll just spin up a node. Well, if Ledger's got attacked, then these types of things are going on. Is spinning up your node safe? Like, how do you know who you're talking to? Like, you you know what I mean? The whole philosophy is everyone should be able to run a node when they need to or want to. Well, if when they wind up needing to becomes a much hairier situation than it is today, then you have to think about these types of issues. Because what good does it do if somebody goes to spin up a node and that winds up not fixing the problem for them? Because they get attacked in one of these ways, because the infrastructure they depended on was not dependable.
And from a game theory standpoint, it's also that because, Peter, you could run your own full node and you don't have to depend on Ledger's node, there is less incentive to attack Ledger's node because you have this great fallback option that they know you'll exercise. If there was no fallback option, the incentive to attack those hubs in the hub and spoke model is much, much higher. If there is a throat to choke, it will get choked at some point.
Okay.
My goal was to scare people with this episode, and I think by Peter's reaction so far, we're doing a good job.
Yeah, well, it just makes me think, well, I'll just hodl. I'll just hodl for now. I won't spend because I've got no idea. Damn scared to receive. Let me ask you a question. If I'm running a multi-sig wallet and I'm using Casa, which means I'm not using a node, I am, say if I'm sending straight to my Casa multi-sig address, and say it's a 3 or 5, and they're all separate keys with separate hardware wallets. So I'm using a Trezor, a Cold Card, and a Ledger. So I'm not using a node for any of those. If I try and, am I in a safer position there when I'm trying to send Bitcoin? And I'm not, or is this? Sorry, I'm not even. I'm just like figuring stuff out in my head. Is this only an issue with receiving because it's blocks on top? Is it an issue with sending as well?
Just receiving, because that's where your node can get messed with.
Yeah, because if you're sending unless the other person is also within that same having that same issue, which is unlikely, so that doesn't matter. So even if I'm receiving and I'm receiving if I'm receiving in my Casa address, do I still have the same risk in a multi-sig address because it's just an address?
Well, so I think we should be careful to not be alarmist, right? Like, I don't think you should worry when you use Bitcoin with a service like Casa today in the UK. I think it's more than likely you're okay. You shouldn't worry, but that doesn't mean you shouldn't think about your security model going forward and how you move the line of defense forward. Those are two different things. And then I think we also want to draw a distinction between a wallet and a node, right? So a wallet, your 305 wallet is just it's 5 xpubs, which are extended public keys, which are generating these addresses. Ultimately, I don't know Casa software well enough, but you're probably using a node that's run by them. They probably have reasonable security. They're probably on top of things. But is Casa's node, does it have a big target on its back? Probably, right?
And also, there actually are things that have already been done to attempt to kind of improve mitigation of these types of attacks. I forget exactly which version it was, but the changes to the peering logic recently in Bitcoin Core to take into account autonomous systems and how many diverse ones you're peering with.
The eviction logic, yeah. Yeah, there's a lot of mitigations in place. And one thing you can always do, Peter, is you can go query the node for the hash of the tip block, for the block tip, and then compare it with some block explorers on your own internet, right? You can do stuff like that
Dhruv,
gain some context.
Have you listened to my show?
I'm a huge fan. I listen to most of it.
Well, so how do you think I know how to do that? The tip of what?
I think your level of knowledge has been such a moving target.
Yeah, of course.
You've learned so much recently.
But hold on. But you just said a thing. What was it you just said? I can go and get the tip of the block. I don't.
Yeah. So the blockchain is kind of like a list of blocks that build on top of each other, right? And the latest block has a hash. It has a hash which is a unique identifier for that block.
Right, so they can't fake that.
Yes, yeah. So if that hash matches with the hash you see on the Blockstream Explorer, and matches with the hash you see, on another explorer, Mempool Space Explorer, then their node is in good shape.
All right, I think really quick here, Dhruv, just to make this clear for Pete, a big part of the reason you can do that is because of the certificate authorities. So that when you connect to that website, you have this guarantee provided by its web certificate that I actually am this website. So it's harder with that website to play the types of games where you're, stopping information from getting there or sending fake information.
And even so, you're still trusting that Casa, Blockstream, and Mempool Space aren't colluding. Ultimately, nothing is going to beat the level of security guarantees you can get from running your own node. So I do really think you should run your own node. And I'm sure Casa lets you point your Casa wallet to your own node.
This is only an issue with new nodes, right? But there is a potential with already running nodes. Right. I feel sorry for the listeners because they're going to be in two camps. There's going to be a camp who are a really smart and going, oh, fucking LP, you're just an idiot. If you didn't read, if you did your work, you'd figure this out. We know this. And there's going to be another camp going, huh? What? I didn't know about these risks. I didn't know someone can do this to me. I don't know if I'm being scammed. I don't know if the blocks I'm receiving are real blocks now.
Well, see, here's the thing. The example of checking the block hash on a Block Explorer website. It's the certificate authority and the fact that connection to that website is encrypted that adds some security guarantee there. Because like Dhruv said, the peer-to-peer communications between Bitcoin nodes is not. So you can play any game you want with that stuff. But when you connect to a website like that, as long as the certificate authority is not malicious or not compromised, then that's Blockstream that you're talking to, and it's an encrypted channel. So your ISP, if they try to stop data from getting there, or they can't put fake data in there, all they can do is stop, but they don't know what they're stopping because they can't see anything. And so, like, as long as you trust or can trust the certificate authority, like cross checking these other sources of information actually does provide that extra guarantee that your node is not being messed with.
And I want to add something which also probably makes the people who are worried feel better, is that today the amount of monetary value backed by Bitcoin's network is at a level. So all of these attacks, if exposed, involved a tremendous loss of credibility of the attacker, whether that's the government, whether that's ISP. If they're exposed, they lose credibility in a big way. The monetary value in the network is at a point where that credibility is still probably worth more to a lot of people. Okay. It's when the value backed by the network goes up, like 10x, 20x from here, that and they are losing ground anyway. That's when they are not worried about losing their credibility. These attacks are not, they will eventually get exposed. In the meantime, people will do transactions they thought were real, but weren't real, so on and so forth. So I don't think today, the reason they're not prevalent is, big ISPs are not willing to lose their credibility over stuff like this. But what happens a decade from now? And we have to be ready for what happens a decade from now.
And most importantly, users need to understand these tools to deal with a decade from now and what the landscape is to protect themselves. Like, it does no good if all of these things are built and then users don't know they exist, don't know why they exist, and don't use them. Like, they have to know and actually use them.
But so can you fix this, Dhruv?
Yeah, so the projects I mentioned, BIP 324,
Yeah.
it adds end-to-end encryption, makes censoring Bitcoin traffic very difficult or nearly impossible, and then authenticated seeds on top of that. Using BIP 324, once we authenticate the seeds, the seed nodes cannot be hijacked via DNS or BGP hijacks. And those projects are already underway.
So, and how long do you think that's going to take?
BIP 324 was a 2019 BIP that saw significant traction in 2019, 2020. And recently, I've been in touch with Jonas to help move that forward faster as well. I can't, like in Bitcoin, it's hard to give you timelines, but this is my full-time thing, is I want to move BIP 324 forward and I want to authenticate the seeds. I know Jonas Schnelli is, already put in tons of work into it. So it's hard to give timelines, but I would like to get it done in the next year or two.
And when it is done, this would be what, batch released as part of a soft fork?
So there is no soft fork. That's a great question. The way BIP 324 is written is it's opportunistic encryption. Okay, so let's say I run an old node that doesn't understand this new encrypted protocol. Mm-hmm. You are running a brand new node because you're diligent and you upgraded your node to the latest release. If your node tries to initiate a connection with my node via this encrypted protocol and I don't understand it, I drop it, you can connect with me via the unencrypted protocol. And so it's not that the network gets fragmented, but if most people don't upgrade, the encryption benefits will not really come through.
Yeah, so that's the important thing, is like, it's not necessary, but we want people to.
Yeah, and we see pretty reasonable upgrade rates across Bitcoin Core nodes. So I feel optimistic about it, that when it's ready, people will use it.
It's like, Pete, and to go a little deeper real quick, like when you're talking how nodes communicate to each other, like that never requires a fork. Like that is completely disconnected from the consensus layer of things. And there's actually proposals, like I think Antoine Riard's AltNet, that want to kind of change core so that you can plug and play any protocol for nodes to talk to each other into Bitcoin Core a lot easier, so that we can have a lot more diversity in connections to protect against these kinds of things.
So I guess I understand what the attack is. I definitely understand what the attack is and not how it's being deployed, but I understand what's happening on my node. I understand that I'm receiving fake blocks. I understand how that can affect me in terms of imagining I've received Bitcoin and then there being a reorg and I lose it. I understand all that. That all makes sense to me. I don't know how to check, but as you said, I can check the hash of a block, and that's not too difficult to do. I can get the hash from my node. I use Umbrel, so I can get it from within the browser. I could go to Blockstream or any other and probably check a couple if I felt like I needed to.
Mm-hmm.
I mean, the reality is like I've been running my node for a while, so I'm pretty sure I've not been subjected to this attack. But at the same time, it would be very, very interesting to go through the process. But ultimately, it's just like another thing. This is the kind of thing I say that really pisses people off. But like, I don't want to care about. I just want you to fix it.
Oh yeah, yeah, yeah.
Yeah.
And we should, like, if we want worldwide adoption, we can't have everybody learning the details of DNS and BGP hijacks. It's not that's not how it should work. And that is precisely why, even though today you could mitigate the attack with Tor or a VPN, what we want to do is we want to upgrade the protocol that comes kind of batteries included with one of the releases, and it just upgrades your node and you get the benefits, right? We don't want a world where everyone has to learn everything.
I'm pretty sure doesn't Umbro come with Tor packaged into it?
I have not used it, but probably does.
So if it does, do I not have to worry about this anyway?
Are you using it? I would be surprised if Umbrel was Tor by default.
I thought it was. Perhaps it isn't. I don't know.
So here's the issue with Tor. The block propagation times are really, really slow on Tor.
Right.
Because you have the 3 hops. There's only so many other nodes on the Tor network. So it really depends on your configuration. Some nodes are configured as in they allow ClearNet as well as Tor peers. And so then your block propagation times are okay, and you're getting some security by being connected to the Tor nodes. But if you really wanted to go all in, you would be all Tor, and then block propagation times would be much slower, which is a different problem.
Oh man! Every time I think I'm getting somewhere, I take a few steps forward and then I get a few steps back because I'm like, oh, yeah, okay. Well, listen, look, I'm sure this is super interesting. People listening will. Certainly some people listening will be like, wow, definitely there's going to be a group of people with my audience are going to be like me, like, huh? But okay,
hey,
I'm glad you're working.
We can go another step further for like 10 minutes or so if you're down, Peter.
Yeah, let's do it.
And I could argue how Bitcoin and things built on top of Bitcoin could actually help fix 2 of the problems regarding internet infrastructure. DNS and certificate authorities. Like, ultimately, all those things is some authority arbitrarily connects 2 things. Like, they take google.com and they connect that to Google's IP addresses, and then they go, this is so, and they pass it down to all the other DNS servers. It's kind of like a hierarchy where you have the ones in charge, and then you have ones below that are just easier for people to connect to. And all the information ripples down, and that's what it is. Well, one of the first altcoins was actually Namecoin, specifically a system using a token in a blockchain. And the token is not necessarily required for this type of thing if you design it right, where anybody could openly get a name like that, a namespace that's easy for people to recognize, and connect that to IP addresses or servers to connect to. And that blockchain, verified with proof of work, allows you to, there's the same kind of thing, but no hierarchy. It just propagates out to all the other servers. And they now know which key is tied to this name and this like server address. And so you could have a domain name system like that provides the same auditing and a guarantee where it's real easy for a user to do. But there is no central authority that can just arbitrarily revoke things or change things without proving the correct authentication mechanism. Like they have the right key tied to that to change something related to that domain name. And so you could actually build something on top of Bitcoin that ironically helps alleviate a centralization issue of the internet itself.
So that's really interesting. What you're saying is that DNS is essentially a database, and you can use a distributed ledger to maintain that database. The follow-up question I would have is, how do you then bootstrap a node that's trying to maintain that ledger?
Well, you got to piggyback on top of Bitcoin's proof of work, which would be the only rational thing to connect that to, and then validate everything. And also just by the nature of this, you can have proofs for inclusion or lack of inclusion if you want to canonically order things. It's not Bitcoin itself. You can make a lot of design decisions. So you could even go in a direction making the validation of it as modular and lightweight as possible, where you can validate certain things without having to fully validate everything.
That I guess, like, that, I'm not sure that answers my question. My question is, I'm spinning up a new node that's going to keep this distributed ledger of this distributed DNS. I still have to ask someone who are the other peers I talk to for this distributed ledger. Because the internet is fundamentally a query response system. You have to ask a query and get a response.
I see what you're saying. The idea would be to piggyback on top of Bitcoin with a canonical commitment, like say a chain of transactions starting with an identifiable transaction, committing to the state of things. And so as long as you can bootstrap into Bitcoin itself, then you can use that anchor point as a way to bootstrap into this new DNS system.
I see. So you kind of mitigate the risk on the Bitcoin layer using BIP324 and authenticated seeds, and then build a distributed DNS system on top of Bitcoin. That's fascinating. Yeah, that makes sense.
And the same kind of logic, just a different cryptographic commitment structure, but you could do the exact same thing with certificate authorities, allow people to opt into that. Although that would be a lot harder to deal with, because now we have to have the politics conversation of make all of the browsers let people just incorporate their import their own authority key.
Wouldn't you have to make public the private keys of the people that were having certificates issued to them?
Well, no, because my whole thought process there would, people could self-issue, and then people could form their own authorities that people would choose to trust or not, and then simply notarize things based on that.
Like a web of trust model. Yeah, fascinating.
Okay. Well, listen, is there anything else to add to it?
No, I'm good.
Well, I'm going to put this one out there.
Be very scared of the NSA, Peter.
Yeah, well, I mean, listen, you don't have to be. I spoke to them this morning. They're not worried about this right now. They're watching Elon. Listen, if people want to follow your work and they want to ask you questions, get in touch, because they're not going to ask me about this one, because I'm clearly vastly out of my depth. How do they get hold of you, man?
Yeah, so I'm on Twitter. My handle is Dhruv, DHRUV, like Victor V. Yeah, I'm happy to get questions and have conversations and learn along the way.
Shinobi.
Yes.
You don't need to tell everyone where you're from, but thank you for joining us for this. This was interesting, and it's making me think quite a bit, but I need to let my brain turn over. I'm probably going to have to re-listen to this one, which I don't ever do in my shows because I hate my voice. But I think I need to just go back and listen to this one and try and take this all in. But listen, praise you for your work, man. I do these shows. I did one the other day on the Lightning Network. That actually came out today with Christian Decker and I think it's Carla Cohen. And again, it was like a whole bunch of shit. I have no idea what they're talking about. I'm just glad they're working on it. And so it's the same I can say to you. I'm just really grateful we have people like you, amazing people working on this stuff and looking to the future of Bitcoin and making it as robust and as strong as possible. And I also want to congratulate us all for getting through this interview finally.
Yeah, and likewise, Peter, I have to say your podcast is one of the. It was a big part of my orange pilling process. So
Well, I guess,
thank you for doing the work you
no
do.
worries. I guess that's more for what other people said than me, but that's brilliant, man, and I appreciate it. And I heard some little bit of sound in the background, but I think we can get rid of that. But appreciate you, man.
All right, Peter, you got to promise me one thing though. When this episode drops,
Yeah.
you need to include a poll in the thread, asking whether after listening to this, people got a little scared or not.
Well, I think they will. But what I'd be more interested in is like two polls. Do you understand what the attack that Dhruv is talking about, and are you scared? And do you not understand the attack, and are you scared? Because there may be people who understand it. They go, yeah, I understand it. I'm not scared because I know what the fuck I'm doing. And I think that's what it's going to be. People who understand it are like, they're not worried. People like me are like, be like, oh shit, this sounds scary. I don't know how to deal with this. But look, we'll put it out there. It'll be interesting. It's great.
Just by inner troll. I'm morbidly curious.
Yeah. No,
it's not the first time Peter would have contributed to crashing the price of Bitcoin.
Dude, listen, that wasn't my fault. Fucking Elon Musk. All right, dudes, love it. Brilliant. Glad we got there in the end. Shinobi, I will talk to you next month. And Dhruv, man, stay in touch. Like, keep letting me know what you're working on. If you need me to tweet anything out, let me tweet it out. If you've got something else to come back on the show and talk about, please come and do it. It's been great talking to you, brother.
Thank you so much for having me.
No worries, anytime. Peace out. Peace out, Shinobi.
Toodles.